Parkinson's disease is this incredibly common neurodegenerative disorder, but diagnosing it, it's always been a huge challenge. But what if? What if the key to getting a faster, more accurate diagnosis was hidden in something as simple as the sound of your voice? Well, a fascinating new research paper is digging into exactly that. They're using AI to listen for these tiny clues that the human ear just can't pick up. So how on earth can a simple sound wave uncover a disease this complex? Let's get into it.
10 million. Just let that number sink in for a moment. That's the estimated number of people worldwide living with Parkinson's. And to give you some perspective, that makes it the second most common neurodegenerative disorder out there, right behind Alzheimer's.
Okay, so here's the paradox, right? For a disease that's so widespread, you'd think diagnosing it would be pretty straightforward. But it's not at all. And that really brings us to the core question we're going to unpack here. Why is something affecting so many people so hard to pin down?
All right, so this brings us right to what researchers call the diagnostic dilemma. It's all about that challenge of being certain, of getting a confident diagnosis, especially when the disease is just starting out.
So, what are these hurdles? Well, for starters, there's no single gold standard test for Parkinson's. There's no blood test or brain scan that can just give you a definitive yes or no. Instead, doctors have to rely on clinical evaluation, basically observing motor symptoms like tremors or rigidity. And as you can imagine, that's really subjective. It's prone to human error, and the whole process can drag on for months, sometimes even years. And this really just lays it all out, doesn't it? On one side, you've got the current process, which is subjective, slow, and pretty error-prone. But on the other side, that's the dream. An ideal diagnosis that's objective, fast, accurate, and totally non-invasive. And that is exactly what this new research is aiming for. So, where could we possibly find a test like that? Well, the answer might be hiding in plain sound. Yep, researchers are now convinced that the human voice holds these critical clues. They think that by analyzing something as simple as a sustained ah sound, we could unlock a deep secret about a person's neurological health.
Now, there's a clinical term for this, hypokinetic dysarthria. It sounds complicated, but the idea is pretty simple. Parkinson's affects the part of the brain that controls movement, right? Well, that includes all those tiny muscles we use for speech. When those muscles get weaker, you get these vocal changes. And what's really important is that this is a common and often a very early symptom.
So what are we actually listening for? What does this sound like in the real world? Well, you might hear a voice that's become a lot quieter, with less power behind it. It might sound a bit harsh or breathy. Speech can get really monotonous, kind of flat, losing that normal up and down pitch. And even the way consonants are formed can become less sharp, less precise. These are the kinds of audible fingerprints the disease can leave behind.
And look, this isn't just some fringe idea. The scientific community is really taking this seriously. The source paper puts it perfectly. The presence of recognizable speech disorders in PD patients is driving the development of non-invasive voice-based assessment technologies. Basically, the clues are there. We just need a smarter way to listen. And that brings us to the AI detective. This is where things get really, really interesting, because the approach these researchers took is what makes this whole study so groundbreaking. They didn't just do what's been done before. They decided to have their AI analyze the voice in a completely new way.
Okay, so check this out. On the left, you've got the traditional way of doing this. AIs usually look at spectrograms, which are basically just pictures of sound. But think about it. When you turn audio into a picture, you might lose some of the really subtle, important details. But this new approach, they have the AI listen directly to the raw audio waveform, the pure, unedited signal. The bet they're making is that this raw signal is packed with tiny patterns that other methods have been missing all along.
But there was a huge obstacle. For any AI to learn to spot these super subtle patterns, it needs a ton of data to learn from. We're talking a massive library of voices. The problem is, medical data sets are almost always small because of privacy rules and all sorts of other challenges. The data set they started with here had only about 300 recordings. For a powerful AI model, it's not enough, not even close.
So what do you do when you just don't have enough data?
Well, this is where the researchers got really clever.
Their solution was brilliant. If you can't find the data, you create it. And this is where the real ingenuity of generative AI enters the story.
They used a special kind of AI called a generative adversarial network, or a GAN for short. The easiest way to think about a GAN is like this. It's two AIs locked in a constant competition. You've got one called the generator, whose whole job is to create fake data. And then you have the discriminator, whose job is to try and spot the fakes.
This artist and critic analogy is perfect for explaining it.
So, think of the generator AI as an apprentice artist, or maybe a forger. It creates a synthetic voice recording of someone saying, "ah." Then, the discriminator AI, who's like a master critic, looks at that fake and compares it to all the real recordings it has. It then tells the artist, "nope, that's not quite right, try again." This whole feedback loop goes on millions of times, with the artist getting better and better, until its fakes are so good that the master critic literally can't tell the difference anymore.
And the result of this whole process was incredible. They took their tiny dataset of just 300 recordings and blew it up into a massive library with thousands of new, totally realistic voice samples for both healthy people and Parkinson's patients. Suddenly, their AI detective had all the data it could possibly need to learn from.
Which, of course, brings us to the big payoff, the moment of truth. With this huge new library of voices to train on, how well did the AI actually perform? Let's take a look at what it found.
All right, first up, let's look at the baseline. So when the AI model was trained only on that small original dataset, its accuracy was only about 57%. To be honest, that's barely better than flipping a coin. Not great.
But now, look at this. After they trained the exact same model on all those thousands of new AI-generated voices, the accuracy jumped all the way up to 73%. I mean, that is a massive, dramatic leap in performance.
Yeah, to be precise, that's an improvement of over 15%. That one number really shows the power of this idea. It's proof that generative AI can help solve one of the biggest problems in medical research, not having enough data.
So, okay, why does this matter so much? What's the big deal? Well, it's because this points the way to a future diagnostic tool that is completely non-invasive. All you need is a simple voice recording. It's low cost, so no expensive machines. It's objective, so it reduces human error. And, maybe best of all, it could be used remotely, from literally anywhere. This could be a total game changer for improving access to healthcare and catching Parkinson's years earlier.
And it's not just that it beat its own baseline score. Get this. When you compare it to the previous best method that also used raw audio, this new approach is still way ahead. Accuracy went up by almost 9%. But the number that really blew me away is the sensitivity. That's the model's ability to correctly identify someone who actually has the disease. It jumped from a mediocre 58% all the way to nearly 99%. That is huge. It means the system almost never misses a case, which is absolutely critical for early detection.
The researchers themselves summed it up perfectly in their conclusion. Their work, they say, underlines the potential of raw audio waveform analysis to improve early detection of PD, opening up new lines for research and clinical applications. It really just highlights how much potential is locked away in our voices, waiting for the right tools to find it.
So that really leaves us with one final, pretty mind-blowing question. If an AI can learn to hear the hidden signature of Parkinson's in our speech, what else could it hear? What other secrets are hiding in our voices? This research really suggests that our voice, this thing we use every single day without a second thought, could one day become this incredible, powerful window into our overall health. Just think about that.